All right, good morning, class. This is Mr. Lyles here. We are on page 42 of our book, lesson 1, and we're going to talk about planet Earth. Okay, right at the top, before we get into the text, it says, "It matters because," and then it says, "We learn about the processes that change Earth." Okay, so again, page 42, and the big bold red, that's where we're going to start. Looking at Earth is the title. And it provides a guiding question. We won't focus too much on, but the guiding question is, what is the structure of the Earth? So everybody get where I'm at, page 42, very first paragraph. Ready? Read. Earth is one planet among a group of planets that revolve around the sun. The sun is just one of hundreds of millions of stars in our galaxy. Because the sun is so large, its gravity causes the planets to constantly orbit or move around it. Please keep in mind the words highlighted in yellow are your vocabulary word. Orbit means to move around it. Continue to read. The sun is the center of the solar system in which we live. Earth is a member of the solar system. Planets and the other bodies that revolve around the sun. Earth and the sun. Next paragraph. Ready to read. Life on Earth could not exist without heat and light from the sun. Earth's orbit holds it close enough to the sun, about 93 million miles, to receive a constant supply of light and heat energy. The sun, in fact, is the source of all energy on Earth. Every plant and animal on the planet needs the sun's energy to survive. Without the sun, Earth would be a cold, dark, lifeless rock floating in space. As Earth orbits the sun, it rotates or spins on its axis. The axis, vocabulary word, pay attention. The axis is an imaginary line that runs through Earth's center from the North Pole to the South Pole. Earth completes one rotation every 24 hours. Test question. Pay attention to that. As Earth rotates, different areas are in sunlight and in darkness. The part facing toward the sun experiences daylight, while the part facing away has night. Earth makes one revolution or trip around the sun every 365 and 1/4 days. This is what we define as 1 year. Every 4 years, we're at the top of the next page, page 43. Every 4 years, the extra force of a day are combined and added to a calendar as February 29th. A year that contains one of these extra days is called a leap year. All right, big red print inside Earth. We're at the next paragraph. Ready to read. Thousands of miles beneath your feet, Earth's heat has turned metal into liquid. You do not feel these forces, but what lies inside affects what lies on top. Mountains, deserts, and other landscapes were performed over time by forces acting below Earth's surface, and those forces are still changing the landscape. If you cut an onion in half, you will see that it is made up of many layers. Earth is also made up of many layers, and onion's layers are all made of onion, but Earth's layers are made up of many different materials. Layers of the Earth. Next paragraph, ready to read. The inside of Earth is made up of 3 layers: the core, the mantle, and the crust. The center of the Earth, the core, is divided into a solid inner core and an outer core of melted liquid metal. Surrounding the outer core is a thick layer of hot dish rock called the mantle. Scientists calculated that the mantle is about 18,000 miles thick. The mantle also has 2 parts. When volcanoes erupt, the glowing hot lava that flows from the mouth of the volcano is magma from Earth's outer mantle. The inner mantle is solid like the inner core. Magma is melted rock. The outer layer is the crust, a rocky shell forming the surface of the Earth. The crust is thin, ranging from about 2 miles thick under oceans to about 75 miles thick under mountains. And it has a ready read. The deepest hole ever drilled into the Earth is about 8 miles deep. That is still within the Earth's crust. The farthest any human has traveled down into the Earth's crust is about 2.5 miles deep. Still, scientists have developed an accurate picture of the layers in the Earth's structure. Now, accurate is in bold but not highlighted in yellow. That's an academic vocabulary that means to correct. Okay, so go back. Scientists have developed an accurate picture of the layers in the Earth's structure. Next sentence, ready to read. One important way that scientists do this is to study vibrations from deep within the Earth. The vibrations are caused by earthquakes and explosions underground. From their observation, scientists have learned that materials are inside Earth and estimated the thickness and temperature of the Earth's layers. Earth's physical systems. Next paragraph, ready to read. Powerful processes operate below Earth's surface. Processes are also at work in the physical systems on the surface of the Earth. Earth's physical systems consist of four major subsystems: the hydrosphere, the lithosphere, the atmosphere, and the biosphere. About 71% of Earth's surface is water. Test question. About 71% of the Earth's surface is water. The hydrosphere is the subsystem that consists of Earth's water. Water is found in oceans, seas, lakes, ponds, rivers, groundwater, and ice. Only 3% of the water on the Earth is fresh water. Test question. Only 3% of the water on the Earth is fresh water. Only about 29% of the Earth's surface is land. Land makes up the part of the Earth called the lithosphere. Landforms are the shapes that occur on Earth's surface. Landforms include plains, hills, plateaus, mountains, and ocean basins, the land beneath the ocean. The air we breathe is part of the atmosphere, the thin layer of gases that develop Earth. The atmosphere is made up of 78% nitrogen, 21% oxygen, and small amounts of other gases. The atmosphere is the thickest at Earth's surface and gets thinner higher up. 98% of the atmosphere is found within 16 miles of the Earth's surface. Outer space begins at 100 miles above Earth, where the atmosphere ends. The biosphere is made up of all the living on the surface of Earth, close to the surface or in the atmosphere. All people, animal, and plants live in the biosphere. All right, last portion for today, seasons. Okay. Fruits such as strawberries, grapes, and bananas cannot grow in cold, icy weather. Yet grocery stores across America sell these ripe, colorful fruits all year, even in the middle of winter. Where in the world is it warm enough to grow fruit in January? To find the answer, we start with the tilt of the Earth. Earth is tilted 25.3 degrees on its axis. Test question. If you look at a globe that is attached to a stand, you will see what the tilt looks like. Because of the tilt, not all places on Earth receive the same amount of direct sunlight at the same time. As Earth orbits the sun, it stays in its tilted position. This means that one half of the planet is always tilted toward the sun, while the other half is tilted away. As a result, Earth's northern and southern hemispheres experience seasons at different times. On about June 21st, the North Pole is tilted toward the sun. The northern hemisphere is receiving the direct rays of the sun. The sun appears directly overhead at the line of the latitude called the Tropic of Cancer. This day is the summer solstice. At beginning of summer in northern hemisphere, it is the day of the year that has the most hours of sunlight during Earth's 24-hour rotation. 6 months later, after December 22nd, the North Pole is tilted away from the sun. The sun's direct rays strike the line of latitude known as the Tropic of Capricorn. This is the winter solstice, where winter occurs in northern hemisphere and summer begins in the southern hemisphere. The days are short in the northern hemisphere, but long in the southern hemisphere. I'm going to pause right there, page 45.